Here's a cool math thing. It's a sculpture puzzle I call GEM that comes as a kit you can assemble. It's built from 60 identical pieces of laser-cut acrylic plastic. I love the way the light plays on it, making reflections and refractions that create a visual depth. It looks really cool if you hang it up on a string and let it spin slowly in the breeze. This video shows me assembling the very first prototype unit. These pieces are covered with a protective layer of paper on both sides, so the first part of the job is to peel the paper off the pieces. It keeps them from getting scratched during the laser cutting process, but getting these corners started is a good workout for your fingernails. After a while, I've made quite a little mountain of the paper bits, and I have a pile of these J-shaped pieces ready to go. You should find 61 parts in the kit, each with a curvy end and a straight end. There's one spare piece in case you accidentally break one. Peeling the paper is the hardest part. After that, the rest will be fun. First, you have to think about which way the pieces face. Try putting 3 of the straight ends together. If they face this way, you'll find that the joint falls apart. But if you turn them around, then they'll hold together well. The reason is that the laser makes a very slight bevel to the edges, so the front and back are not the same size. Now remember which way they should face, and put together 3 of the curvy ends to make a module. You may notice these are 3 90-degree angles, so they fit together just like the corner of a cube. Push to click them into place and they'll lock together tightly. You can make all 20 of these modules and stack them up in piles. If you should accidentally make the mirror image of one and need to disassemble it, try using a small screwdriver to pry it gently apart. Once you've made your modules, they join to each other in groups of 3. We've already used all the curvy ends, so the rest of the assembly uses the straight end of each piece. Again, they lock together well if you snap them together tightly. This is the basic connection, but you must keep in mind that underneath each of these outer joints made from the straight end of the J, there will be another 3-way joint made from the 90-degree corners of the curvy end of the J. Watch how I position another module underneath this outer joint and spin it into place. These are all the basic steps. Now just keep combining modules. Whenever you can, be sure to place an inner joint underneath an outer joint. At first, it'll be easy to slip a new module in from the bottom, but as the sphere starts to close up, that gets harder. Near the end, be sure never to close up an outer joint unless there's an inner joint already underneath it. It's interesting that often when I build modular geometric structures, I find a similar sequence of experiences. At first it's confusing because I've never done it before. The initial puzzle is to figure out the structure and discover how the parts relate to each other. But then by the time I'm halfway done, I've learned the pattern and it's much easier. You get into the flow of it and you feel good about how everything exactly fits where it should. But then near the end, new problems arise. You have to be careful not to block yourself off, and you ponder over the exact sequence of steps that you'll need to finish. Then finally the last piece goes in, and it all looks so logical and easy in hindsight. So when someone studies the crystalline geometry of the completed gem, it may be hard to appreciate how tricky it can all be when only partially complete. I hope you enjoy the puzzle aspect of assembling it and the sculptural aspects of the final result.